Yeah. Good evening, everybody. Welcome to this second part of our discussion on basics in laparoscopy. We had sort of looked at the basics of lighting up the inside, the physiology of gas insufflation, types of gas available and all that. We have a few more things to discuss about instruments and the equipment that we use. But before that, we will look at some of the basic characteristics of laparoscopy and how it differs from open surgery. So can I invite one of our students, perhaps Praveen, to tell us what he thinks about the differences between open surgery and laparoscopy?
Yes, sir. Good evening, sir.
Good evening.
Sir, laparoscopy has a long curve of learning, sir, steeper curve of learning,
Yes.
and it requires hand-eye coordination.
Okay. What do you understand by that?
And sir, normally in open surgery, we will be doing under our vision, and it will be direct vision. But through a laparoscopy, we will be seeing through a single camera, single vision. So
That is not hand-eye
there will
coordination.
be.
What you're describing is monocular
Sir,
vision. Okay. Yeah,
Sir.
but what is hand-eye coordination? Nikita?
By looking at the
Yeah, go on. You're on the right track. Go on.
by looking at the screen, and we should be able to coordinate with the
How is it different from open surgery?
hands.
Okay, when your hands are operating in one area or one plane, and you're looking at it when you're doing it, it's relatively easier. You're looking somewhere and your hand is operating elsewhere. That then needs a kind of coordination, which can be acquired, of course, but that is the hand-eye coordination that's required. So you need to develop that skill. Okay?
Yes, sir.
Okay, go on. You also mentioned about monocular vision. What is that?
Sir, normally we have binocular vision, sir. But through laparoscopy, we'll be having a single camera vision, that is monocular vision.
Okay.
So the depth of the vision cannot be perceived, sir.
Correct. Yeah. Depth is not perceived, and so it's a flat screen, and so you have to then make the adjustments to go at a different depth. All of you, when you start your laparoscopy, you will realize that. You think you're going somewhere, when you're clipping a cystic duct, for example, I give you a clip to clip it, and you really can't get on either side of the cystic duct, which I'm sure every one of us has experienced when we go in. So depth of vision is lost in monocular vision. Yeah, there are also limitations about color perception and hue, but they're not clinically very significant. Yeah, go on.
Yes, and there will be loss of tactile sensation
Correct.
in the laparoscopy.
Very good. Yes. So you don't have a feel of what you're doing, and that is a limitation. Yes.
And in the laparoscopy, control of bleeding is difficult while compared to open surgery.
Correct.
And
all right, Nikita, you want to add anything?
Go
on, Praveen. If you have any more in the list, yeah, go
on. There will be limited area to work, sir.
Yes, limited space. Very good.
Space.
Yeah.
Yes.
Nikita, you want something to add?
I think he covered mostly, sir. Yeah.
All right. What is the fulcrum effect? That's another one.
The angle of the tip of the instrument and our hand are opposite. So the port acts as a lever. So when we're trying to move to the right side, we have to move the instrument to the left side. That difference makes it.
Your handle has to be moved in a different direction to the direction in which you want the tip to move. Correct. Anything else?
And the amplification, sir. If you move a little, it moves a lot.
Always? when does that happen? You're right, but when does it happen? The segment of the instrument inside the abdomen must be longer than the segment outside the instrument, outside the abdomen. That's when a shorter movement of the handle, for example, which is outside the abdomen, will act to increase the movement or the swing of the tip of the instrument. All right, that's important. So it depends on where the fulcrum is in terms of the intra-abdominal versus the extra-abdominal length of the instrument. And if your instrument is exactly, if the fulcrum is exactly halfway in the instrument, then there won't be any change. It will move inside the abdomen as much as you move outside the abdomen. You got that?
Yes, sir.
Yeah, that is the fulcrum effect. What do I mean by tissue approximation? Putting tissues together, be it an anastomosis, okay, be it closing holes, be it closing a tube like a cystic duct, whatever, is because you can't suture very easily laparoscopically. Of course, you learn all this as you go along, but that's a challenge compared to the open surgery. And this is another one. Okay, you may do a resection, quite big resections inside the abdomen. You may take off the spleen, you may take off a part of the liver, take off the whole of the colon or whatever. But taking it out of the abdomen, not all of them can come out of a 10 millimeter incision. So you then have to have certain methods to facilitate specimen extraction. Okay. Now we talked about difficulty in hand-eye coordination. Okay, looking at the screen and working somewhere else down below. What are the tricks that one can use to improve the hand-eye coordination? Vinod.
Practice, sir.
Sorry, practice. Yeah, very good. That's the first thing in everything. I agree. But something more practical, and you must practice the right things, because if you don't exercise the right principles during your practice, your learning will be a drag. So, what are the things that you need to institute before you practice?
No, sir.
Indraja?
Can you hear me, sir?
Yes, I can.
Yes, sir. We have to place the correct port placement, sir. Whatever is the surgery, according to that, we have to place the ports.
Very good.
Triangulation, sir. Triangulation of the port.
Very good. Okay.
And placement of the monitor also, sir.
Excellent. Yeah. What is the principle there?
Monitor, it should be in long axis.
No, it should be in one axis.
Yes, one axis. Sir.
Your hands, your eye,
yes,
the organ in question. This is your eye here.
Yes, sir.
The organ in question. Okay, this is a fundoplication, for example. And the monitor must be in one line.
Yes, sir.
Okay.
Yes, sir.
And so if your eye is here and your camera is looking at you, just try it sometime. It's almost impossible to get the hand-eye coordination. Even after, 3 decades of work, if I have a camera which is coming towards me and I'm standing in one direction, it's almost impossible to get the hand-eye coordination. So this alignment, your eye, organ in question, the camera, your eye is your camera, remember? And the monitor must be in one single axis or one single line. Anything else? What is triangulation to you?
Sir, the port placement should be in the common triangle.
What is it? What is a triangle? How does a triangle form?
Base and 2 arms.
Sorry?
Base and
yeah, but what is, you have to tell me where the base is, and that's what I was looking at, but I've given you the answer here. Eye, organ, monitor in one axis, hands meet at 60 to 90 degrees.
Yeah.
You understand?
Yes,
so
sir.
you have the camera in the middle, your right hand and the left hand are either side of the camera, and they're far enough apart so that at the place where they meet, at the organ that you're operating on, ideally it is between 60 and 90 degrees. And in practical terms, at least 10 centimeters of difference between the two, and then the ports must be about a hand's breadth between the two. Nikita, you have a question.
Sir, does the height of the bed, I mean, the operating table makes a difference in the hand-eye coordination, sir? I mean,
No, it makes a difference for the ergonomics, and we'll talk about it later.
okay.
Yeah. We'll talk about it later. So if you have a situation where the camera is in the middle, telescope, and you have your right and left hand operating surgeons on either side, and they meet at the organ at about 60 to 90 degrees, then you have the best chance of getting a hand-eye coordination. Having said that, there are many people who go parallel to the camera. Both the hands are parallel. Many people finish a whole hysterectomy like that. I have tried it myself, but I'm much more comfortable when there is triangulation. Certainly, when you have to do suturing, you need triangulation. Most people who do, this parallel arrangement do not have to do suturing. They use energy sources to get hemostasis, so they don't usually suture. They may at the most put a clip, but if you're doing suturing, you will need some kind of triangulation. Even though some I know have seen people try and in fact succeed in putting a suture even in the parallel arrangement, but that is exceptional. Okay. So one of the things that Praveen said was that hemostasis is a challenge. So what are the tricks available for you in laparoscopy to attain hemostasis? Whom shall we ask? Shall we ask one of our guests? Don't have too many guests today, I guess. There's something that says iPhone. Who is that, please? Can you rename yourself?
Yeah, hi. So this is Sahana, sir.
Sahana. Okay, I'll rename you. Can you tell me what are the tricks you have for
First is pressure.
Pressure? Yeah.
And then we can use our energy.
Okay. How do you put pressure?
Maybe with a bowel grasper we can apply pressure and hold it for around.
What do you use to put pressure on? Suppose you have bleeding from, say, cystic artery, one of the commonest operations that we do. How would you put pressure on it?
With a cotton swab.
Okay, you can put a gauze piece inside. Okay. Any other alternatives?
With a Maryland, if we can precisely hold the
that would be relatively dangerous. We're talking about pressure. We're not talking about actually clipping or holding it. Gauze piece is definitely an option. Would you be able to put a whole gauze piece into the abdomen? What else would you have to do?
We can put a whole gauze piece into the abdomen.
What do you
do? We have to tie a thread to the end of the gauze piece.
Okay.
And leave the thread outside so that it won't. We can remove it out easily.
That's a bit of a tall ask. It's difficult to keep it out because when you keep it out, I mean, I know some people do it, but when you keep it out, then you have an issue with putting other instruments and things through the same port. Okay. Yes, but the thing to do is to make it into a smaller, not the standard size gauze piece, but make it into smaller pieces and wrap it up or roll it up so that it fits into a reducer and then push it in. Okay.
Yes, sir. Okay, sir.
And don't have more than one gauze piece at a time. That's the principle I use. Use it for pressure, and once the job is done, take it out until you put the next one in if required. So apart from the gauze piece, what else would you use? You can use omentum, which may come up to that area.
Yes, sir. We can use omentum.
Yeah, you can. If you have half removed the gallbladder, and the gallbladder is still there.
Yes,
stop retracting away from the area and just take that half released gallbladder, any organ that can, and put it up there in the pressure.
Yes.
And do not remove it and keep testing it every half a minute, whether it's bleeding has stopped or not.
Yes.
Keep a sustained pressure for 3 to 5 minutes without disturbing that pressure. Okay, the only time you disturb the pressure is if you find blood oozing all around the place where you have put a pressure, which is very, very rare. So if you have achieved relatively good hemostasis, put pressure there and that's all you have to do. Okay, pressure is one of them. What else can you use? Use energy sources.
Yes, sir. We can use energy sources.
Okay. What else?
We can use those gel foams.
Yes, you can use that. clips and staplers, depending on where you are. Okay,
Yes, sir.
so you can use swabs, you can use organs, coagulation, energy sources, hemostatic agents. You mentioned gel foam, which is right. You can have clips. You can have, if you can actually identify and hold the bleeding vessel, you can even try and tie it. You can suture it, and in certain instances, you can even put a stapler across. It depends on where the bleeding is. So these are the tricks that are available for getting hemostasis. Energy sources is a very important thing, but it's a class by itself. So I'm not going to talk about energy sources in this group discussion. Okay, so we talk about monopolar coagulation and bipolar coagulation. So Nikita, come in and tell me what are the advantages and disadvantages of each of these.
Sir, unipolar coagulation, it is used for only like damaging the tissues of cautery ignum.
You can use it for hemostasis also, but what would be its problem?
It can't hold the tissue, sir. It just
You can hold the tissue. You can use a Maryland, hold the tissue and burn it.
it needs a grounding, sir.
Grounding is there, and so in terms of a laparoscopic approach, what is the potential problem? All the laparoscopic instruments are covered in black, most of them, 90% of them. Why is that? What is that black thing there?
Insulation.
Insulation. Why is that given?
To avoid electrical injuries, sir.
Yes, so that is the real issue, that the disadvantage of the monopolar. Particularly, remember that you're only seeing a bit of the field that you're working in, unlike in open surgery, okay? So if your tip is holding something deep in the pelvis, and the shaft of the instrument is touching bowel somewhere, all right, which you're not even seeing that it is touching bowel. And if the insulation is less than adequate, you can have a bowel injury. That is the downside of a monopolar coagulation. So what you have to do is, when you're working in depths where you feel that there's a potential for the shaft of your instrument to touch some other organ. It could be the bowel somewhere, it could be liver or whatever, it could be uterus or the ovary or whatever. So if you have a potential for the shaft to touch any other organ, then it is better to use bipolar. Because in bipolar, the electrical discharge is only between the two jaws of the instrument, and you're seeing the whole of that area where the electrical activity is going on. But what is the disadvantage of bipolar? Anybody? Indraja?
Sir, it is only hemostatic, sir. It does not cut the tissues, sir. Bipolar.
Even theoretically, even unipolar coagulation doesn't cut tissue. Okay, doesn't cut tissue. Yeah.
So it takes a longer time to.
Yeah, it takes a longer time, not as efficient as monopolar, and so some impatient surgeons may find it difficult to keep using bipolar for a long operation. And I belong to that category. So only when I find that I use monopolar most of the time, and when I find this limitation where when I'm working in the depths, like in the pelvis or in the subdiaphragmatic space or in the retroperitoneum while doing something on the kidney or the adrenal or something like that, there I use bipolar coagulation. What is ligashure? And these are trade names, but these are basically known as vessel sealers, both of them. What's the difference between a vessel sealer and the first two kinds of coagulation? Vinod? Pavan here, I have not spoken to him at all. Pavan, are you here? It's your turn, man.
Sir. Hello.
Yeah, go on, Pavan.
Sir, vessel sealer, it contains coagulation.
Is it a bipolar or a monopolar? Or
Bipolar,
neither?
sir.
Or neither?
It's a bipolar.
It's a bipolar. Okay.
Yes, sir.
All right, agreed.
And we can use it for both coagulation and cutting also, sir.
Okay. How is it different from a regular bipolar?
Sir, in regular bipolar, we can't do cutting, no, sir.
No. Not all vessel sealers are cutters.
Okay,
They incorporate a little knife in it, and that causes the cutting. But in the actual process of coagulation, what's the difference between a vessel sealer and a bipolar? Anybody? Who, Jivita, can you identify where are you? What are you doing? What's your
Good evening, sir. I'm from AV Hospital, sir.
very
Gynac
nice.
fellow, sir.
Okay, you're a fellow. Okay, you should be able to use a lot of it. Yeah, good.
Yes.
So tell me, what is the difference between bipolar and ligashire?
Sir, ligashire is a modified bipolar used for sealing vessels, sir.
Yes. So how is it different from a bipolar? Is my question.
Bipolar can be used for
important
both
points.
cutting and coagulation.
No. Cutting is a function. It's not incorporated. There are only two main important issues. One of them is that the vessel sealers can deal with bigger vessels up to 7 mm diameter. Okay, the way they're designed, they can coagulate bigger vessels. And second, and this is in fact more important than the size of the vessel, they have built-in sensors which can sense the impedance. So when there is a blood-filled vessel, it has a degree of impedance. Impedance is the capacity or the property which allows current to pass through. And when the blood gets coagulated and the vessel gets sealed, this capacity for the current to pass through, the impedance of that structure changes. Okay, and these vessel sealers have the capacity to recognize the change in the impedance. And once you have been coagulating them, it gives you an auditory signal to say that the impedance has changed, which means the vessel is sealed, at which point you can stop your coagulation and cut the tissue, either with the inbuilt knife or with a scissors or whatever else that you use. So the important difference is that a vessel sealer has a capacity to measure the impedance and tell the surgeon that the coagulation is complete. Okay, how does harmonic scalpel work? Again, Jivita.
Harmonic scalpel is both cutting and coagulation energy.
Yes,
it also has
what is its principle? Does it have any electricity there? What is it? Sahana, I didn't ask. You're right. It is also called ultrascission. So what does that mean to you? It basically deals with extremely high frequency, sound waves, as it were, which causes so much disruption or so much excitation of the tissues that the tissues coagulate and also get cut. Okay, and it is through the vibration of what is called a piezoelectric phenomenon of a crystal, which has the piezoelectric phenomenon that vibrates at such a rapid rate that it produces a very, very high frequency wave that causes the coagulation and the cutting. That's a harmonic scalpel. This actually is an overview of the energy source. But as laparoscopic surgeons, we should have a separate class, learn about the principles of monopolar, bipolar, and all these things in greater detail. Okay, what I've given you is a principle or an overview. Okay, all right. We talk about tissue approximation. What are the tricks that we have for tissue approximation? Go on, Pavan.
Sir, suturing, sir.
Okay.
Intracorporeal and extracorporeal.
So something before suturing?
Sir,
ligation.
Ligation, sir.
Okay. Suturing. Okay.
And staplers, sir.
Staplers. Clips.
Clips.
Yeah.
And
anything else that we don't normally use but can be used?
Yes, sir. Tissue adhesion.
Yes, very good. Tissue adhesives can be used, and laser welding. You can use a laser, is an energy source, to do the same thing. All right. So what is the difference between an extracorporeal and an intracorporeal suturing or knotting?
Sir, in extracorporeal knotting, we will do outside. That means we will do extracorporeal knots and like slip knot, Roder's knot we will put, sir.
All right.
And
is it strictly a slip knot?
No, sir. No, sir.
So what is it?
Yes, sir.
Starts off as a slip knot, but the important thing is the knot is fashioned outside the abdomen.
Yes, sir.
It forms a slip knot as a semi-slip knot is the word I would use for that. And it slips down,
Okay.
you can push it down into the abdomen, tie it where you want. And when you actually tighten it by pushing the knot down onto the structure, it becomes a firm knot.
Firm knot.
Becomes not a slip knot anymore. That's the way the knot is designed. Okay,
Yes.
intracorporeal, you form the knot inside. So what are the things that you have to bear in mind when you're fashioning an extracorporeal knot? In terms
knot
of the
is
thread
too
that,
tight.
sorry, go on.
The thread length should be 60 to 90
Excellent. So
centimeters.
you have a long thread length, very good, because you have to go in and out, fashion everything. Yes, very good.
The knot shouldn't be too tight.
All right. So that the knot should slip. So there must be, if there is a very high coefficient of friction, okay, where it gets stuck, you can't slide it down. So you use a material which you can relatively easily slide down. Right? And so those are the two simple things, but the important thing is the length. What should be the length in the intracorporeal knot? It should be short.
30,
30 centimeters.
20 to 30 centimeters.
Even less than that. Okay. The reason is if you have a very long intracorporeal thread, you get confused with the different loops of the ball when you fashion the intracorporeal knot. Okay. So you have extracorporeal knots of two types, Roders and Melzers. Okay. Sahana, can you tell me what the difference between the, and can you identify yourself, please, again?
Yes, sir. I'm a fellow in AV Hospital,
Oh, you're
sir.
a fellow. Okay, you're okay. Go on. Okay, I know you, but I didn't place the name. Yeah, go on. What's the difference between the two?
Melzer's knot, we have two loops, two
No, just tell me in principle, where would you use what and why?
when we need a firm knot, I'm not sure, sir. I'm so sorry.
Yeah, no problem. Indraja, want to take it?
No, sir.
No. Roders knot is meant for threads with a better coefficient of friction. All right, like Vicryl, for example. Okay, but if you're using nylon, which is very slippery, low coefficient of friction, then you have to do a Melzer's knot because it is a lot more secure than a Roders knot. Okay, so I'll take you through steps of what we do. Okay. Yeah, you have two throws there. Some people put only one throw for the initial thing. This is exactly like a surgical knot. And you go one round, and on the second round, you put a lock. Actually, I have put two rounds here, but it's actually only one round in a Roders knot. And then bring it up like that and bunch the whole thing down. That is bunching that knot. Okay, and then push it down. All right, that is a Roders knot. So you have to keep practicing this. That's all that there is to it. Okay, and when you do two of those three, sorry, double throw in the first instance, and 2 or 3 rounds around the vertical thing, and 2 knots in the end, that becomes a Melzer's knot. It's just to make it a lot more secure, as I mentioned. Now, in suturing, it's important that you have the triangulation that we talk about. And the most comfortable scooping, the way you do is from 1 o'clock to 7 o'clock position. That is ergonomically the most comfortable position. And the needle holder must be parallel to the suture line, which means the needle, which is mounted perpendicular to the needle holder, will be perpendicular to the suture line. Okay. And if we are looking at suturing, I'll tell you for the sake of saving time, because suturing is a thing that can be learned with effort, but you need to have the principles in mind. It has to be, as people say, like an orchestrated movement in a dance, as it were, steps 1, 2, 3, 4, 5, 6, 7, 8, like that. And first you have to do is loading the needle. You have to do it step by step. So you grasp the needle, the thread behind the swage, that is where the thread meets the needle, let it hang down or have it placed on the omentum or the side wall or something like that to steady the needle. As I said, support it against a peritoneal fold and then load it onto your needle holder, 1/3, 2/3, like in open surgery. But then it may not be sitting perpendicular the way you want it. So the next step is altering deflections. It's also called flipping the needle. Flip it so that it is perpendicular. Then you drive the needle. Most of the time, youngsters tend to take both because it's a job to load the needle. They try to take both edges of the wound in one go, and that's not a good idea. For perfection, you must take it from one lip of that wound that you're suturing and then take it on to the other side after loading the needle again. The exit point, as I said, 2 steps have to be preferable. And then you tie an intracorporeal knot, okay? Like it should be a surgeon's knot. And positioning, as I said, is very, very important. The grasper port must be 10 centimeters away. That is the triangulation. Grasper between 60 and 90. And the thread, as you say, is about 4 to 6 inches long. That's only about 15 centimeters at the most. Because it's better to put several needles into the abdomen when you're suturing rather than to have a long thread. Because if you have a long thread, you end up with trouble. This is the one I talked about, hanging the needle. So the grasper holds the thread behind, this is the swage, and then you grasp the needle there. Okay. So the challenge again is to get the needle in and out, and the thread in and out of the abdomen. Always use a reducer. And if you have a 10 mm port, it doesn't take anything more than 30 cent. The side 30, it should read 30 mm. Okay, this is a typo. It doesn't take more than a 30 mm needle. 25 is even better. And sometimes you can have, if you have straight needles or if you have a 45 centimeter needle, you can straighten it and put it directly into the abdomen. I have seen people who put needles into and take it out of the trocar site, as it were, and I don't recommend it and never do it again, because if the needle gets stuck in the abdomen, then we have an issue. Okay, so I will stop here and ask for comments from Ravi Shankar, Niranjan, from up to what I have said now, and perhaps questions or comments from the students. Ravi?
First thing is, do any of the students know, you asked all the principles of the bipolar and monopolar. Do they know what is the current in them? The bipolar and monopolar. Any of the students? Pavan?
Sir, I don't know, sir. Exactly.
Anybody else? Anyone can answer. Vinod?
Sir, for bipolar, the requirement of current will be more than
Is it
monopolar.
AC or DC is what he's
See,
asking.
that's what I'm asking.
AC, sir.
Huh?
AC current.
For what? AC current for what?
Yeah.
No,
See, I think nobody's answering.
Yeah, that's why we should have a whole class. It's a DC actually.
Yeah.
The way the waveforms are different, but we should have a whole class on it, because all of you laparoscopic surgeons must have a thorough knowledge of these things. Okay, we'll have a separate.
Yeah.
That's why I didn't get into that part of it.
Yeah, yeah.
We'll have a separate class for it. Okay.
Okay.
Anything else?
Other thing is there are certain, for example, Asian Institute, I think this is for the students, Asian Institute insists that when they start a laparoscopic cholecystectomy or an appendicectomy, that they place a half, as you said, a full gauze, we find it difficult to put it in, a half cut gauze, to be kept at the gallbladder, bed or whatever, so that in case there is any bleeding, you can, use it to apply pressure straight away. So that is one, I think, good practice that we all have to probably. And the other thing is, you have to remember that in your quest to achieve hemostasis, you can actually damage the bile duct or other important structures in that area. So whenever you are holding something, you be sure that what you are holding and using the energy sources. But I think all your points are well taken, sir. I don't think there is much to add from my side.
Niranjan, yeah, any comments?
Sir, nothing to add, sir.
Okay.
Everything is covered.
Any questions from the students or even comments? All right. So these are the principles of actually doing the operations, and we go back to the equipment because with the advent of laparoscopy, we now are dealing with a lot more equipment than we were at open surgeries, and it is important for you to understand what these things are, because if you do not know, you do not expect the OT staff to set everything right for you. You must be able, you must have the capacity to set it right for yourself if the OT staff cannot do that for you. Okay, so we said that we need insufflation to create space. Okay, and we also mentioned how people can pump air into the abdomen, and we said why we shouldn't use air and put carbon dioxide in. But why do you need an insufflator? Praveen.
Sir, to maintain to identify the pressure flow rate of the gas we are pumping.
Yeah, why do you need to maintain the pressure?
Sir, because high pressure is
very good. High pressure is harmful, and low pressure.
Low pressure, there won't be enough room for the operating. Sir.
Low pressure means no space. Why would you expect low pressure?
Sir,
if you did not have an insufflator, why would you expect low pressure? Gas leaks.
Yes,
all right.
Yes, gas leaks.
In
Yes,
so many areas around your instrument, even with all these flap valves and washers and all that, it can leak, and so it is inevitable. And so that is why you need an insufflator. So if you need an insufflator, what are the things you expect the insufflator to do? What are its responsibilities? Or what is its job?
So, to maintain the constant pressure, sir.
Correct. So it must have pressure monitors, which tell you what the intra-abdominal pressure is.
Intra-abdominal pressure is.
And then it must automatically trigger inflow of gas. Okay. All right. So that's one. And it must have an alarm which tells you that the pressure is very high. It should stop the inflow of gas, and when the alarm comes up, the surgeon must let the gas out. Okay. Second, what else?
Sir.
Flow rate.
Filter. It should have filters. Sir.
It should have filters. Very good. Even though you get medical grade carbon dioxide, you don't want particulate matter entering the abdomen, so it must have a filter. Yes. What else?
Flow rate, sir.
Flow rate, yeah, that depends on the degree of leak, and so you would want the machine to keep an eye on the flow rate, which it does through the pressure monitors. What else?
Amount of gas used.
Okay, it tells you, may or may not be very significant, but yes, it does tell you the total amount of gas used. Okay.
Also, having a warmer helps.
Yes, very good. Humidifier and warmer. Both are important. When you put cold air into the abdomen, it can cause hypothermia. So it's good to have a warmer, and it's good not to have very dry air being pumped in. So certain insufflators have humidifiers built in. Okay. It has an intra-abdominal pressure pump to insufflate. The flow rate that somebody mentioned, up to 40. Normally it's 20, but if you're doing major operations with multiple trocars and into the abdomen, leak can be very high. And so there are machines available up to 40 liters per minute. So you must have a variable rate of insufflation, but maintain a constant abdominal pressure. Dials show data with audible alarm. So even though you're not looking at the dials, if you have anything untoward, particularly higher pressure, you must have an alarm which tells you that you must do something about it. Okay, those are the requirements and the available features of an insufflator. This is an example of a classic insufflator. So it tells you the intra-abdominal pressure that you set. We normally keep it at 14. This says 15. All right. And flow rate can be adjusted. And this is the total amount of gas that you have put in. These are the three minimal requirements. And this dial tells you how much carbon dioxide is there. Many times when you have a central supply of carbon dioxide, this becomes redundant. If you have a anesthetic pendant or anesthetic machine mounted carbon dioxide, then this will come in handy to tell you how much carbon dioxide is there. But many institutions now have a centrally supplied carbon dioxide as well. Okay. So what should be the intra-abdominal pressure and what should be the rate of insufflation generally? Nikita.
Sir, intra-abdominal pressure we maintain at 14 to 16 mm of Hg, sir.
16 is very, it's generally high, but yes, it can on occasion can be taken to 16, but 14 is the generally accepted figure. That is in a normal adult. When would you consider a different level of intra-abdominal pressure?
If you are doing an tip, sir, in between the planes,
What would you do?
lower pressure would be used, sir.
Not necessarily. Yeah.
And depending upon the obesity.
What would you do in children? And what when low pressure? How low is the question? All right. So it will be about 10 millimeters in the pediatric group. And if you're putting it in the chest, okay, you'll keep it at around 12 and not 14. But in the abdomen, you keep it at 12 to 14. Would you always need a 12 mm or an increased pressure in the thorax when you do thoracoscopy? You have seen Rajshekhar do this.
No, sir.
No. What does he do then, other than putting pressure through an insufflator? You can collapse the lung, right?
Yes, sir.
So that the pressure need not collapse the lung. So what is that called? It's called one lung anesthesia. All right. So
yes,
in thoracoscopy, you have a choice of either doing a one lung anesthesia, or if that's actually preferred, you can collapse that lung and work on the thorax, on that side of the thoracic cavity. Patient's oxygenation and carbon dioxide, other things maintained with one lung, or you may choose to put pressure and collapse the lung on that side if required. And in that is the case, you don't usually use a higher 14 or 16, use 12 millimeters. Please note that the Veris needle can take no more than 3 liters per minute. So don't start with a huge pressure on the Veris needle, because it will give you an abnormally high pressure reading. Okay. But with the trocar, you can put it up to the maximum that the machine allows, depending on the amount of leak that takes place. Okay. Now there is a whole concept of so-called low pressure laparoscopic surgery. So it made, people felt that it had a lot of advantage over high pressure or the normal pressure, that is 12 to 14 millimeters pressure, laparoscopic surgery. But studies have shown that there may be a moderate level of, moderate reduction in the post-op pain. Even the level of evidence is not very strong, but it has no other salutary or good effects like splanchnic circulation or intrathoracic or intracranial pressure and things like that. Okay, there is no other change. So there is no great advantage in reducing the pressure. But as we mentioned earlier, if somebody has a cardiac or respiratory comorbidity where they do not tolerate the usual 14 millimeters of mercury, it's always good to operate at a lower level of 12 or 10 millimeters of mercury. Okay, so how does the telescope work? As I said, this is a class on principles, and I just want to just briefly touch upon them. What is the inside of the telescope like, and what does it do? Praveen.
Sir, it works on bending of light principle, sir.
Does the telescope bend light normally?
No, sir, it
Does it-
uses
It's not a fiber
prisms,
optic.
sir.
Yeah, if you have to bend light, it uses prisms, I agree.
Yes, sir.
What transmits light? Is it vacuum? Is it a convex lens, or what is it? We talk about something. Hopkins was a name given to it. We talked about
Sir.
Hopkins rod lens system, right?
Yes,
You
yes,
remember that?
yes, sir.
Yeah. So these
Yes,
are
rigid
rod
lens.
lenses.
Yes, sir.
Yeah. You have small convex lenses in between these rods that you have, and if you want to bend light for whatever reason, then it uses prisms. You're right about that. So the advantage of a rod lens is the same as, the principle is not the same as a total internal reflection, but the rod lens works to transmit light straight across, and unlike mirrors, there is no loss of light. The clarity is so good
Yes,
that
sir.
there is no loss of light. That is what it is. And what are the variations in the telescope that you can think of, that you have known? You've been in the
Sir.
hospital.
Yes, sir.
Mhm.
Yes, in the viewing angle, sir, it may
Very
be
good.
0 degree, 30
Yes.
degree, 45 degrees, sir.
Excellent. Where would you use what?
Sir, normally we use 0 degree, but
Okay.
to look at the deeper structures,
Yeah.
we
You
needed
have
an
to
angled one.
peep over some.
Peep.
Yeah, you have some bubble
Yes, sir.
sitting there, and you want to look at a depth. You look at some crevice just beyond the bubble mass. There are momental structures. Then you use 30 degrees, or if necessary, in deep structures, even 45 degrees.
45 degrees.
So
Yes,
in
sir.
terms of camera work, what's the difference between a 0 degree telescope that you use and a 30-degree telescope that you use?
Sir, in 0 degree, we have to move the whole camera to the direction to which we want to see.
Okay. It's the same in 30
But
degree
in the
also.
sir, in 30 degree and 45 degree, just you can rotate the camera, sir.
No. The camera is always kept stable. You call it the 12 o'clock position.
Yes, sir.
You call it the 12 o'clock position.
12 o'clock position.
Okay. So those are the dials on top of the camera that will be looking at the roof. That's always constant. So in a telescope, in a 0 degree telescope, you rotate the camera, nothing happens. Okay. It's just looking straight on. All right. But not the camera is 12, but you rotate the lens, the telescope, nothing happens. It's all the same. Whereas if it's 30 degree or 45, all right, if you keep it looking down, it looks down. And if you rotate it 180 degrees, it looks up. But please note, most of the time, the camera is always kept at 12 o'clock position. Okay, depending on which way you want to peep, you can rotate the telescope in a 30 or a 45 degrees to look at variable angles of vision to help in the surgery that you are trying to do. All right?
Yes, sir.
Did you get that?
Yes, sir.
Okay, so that's what is the difference. So please remember that the camera work, when you're using a 30 or a 45 degree, is a lot more tricky, needs a lot more skill than if you're using a 0 degree telescope. All right. Now, what is the thing that works? What is the basis of our video camera? Sahana, can you take that? What actually gives you the picture? I see an Oppo F15. Who is this, please? Can you identify yourself? I'll rename you. Oppo F15.
Sir, I'm Dr. Hina from AV Hospital. I have recently joined in here, sir.
From AV, is it?
Yeah, sir. Surgery fellow.
All right. I'll change your name. Yeah.
Recently joined.
All right. Very nice. So tell me, what is the principle underlying a video camera that you use every day? Okay. Tasmia, Dr. Tasmia, where are you from? Can you unmute yourself, please?
Yes, sir. Sir, I'm also from AV Hospital, sir.
Oh boy, we have very good. All right. So you have the principle, you know the principle of underlying a video camera that you use?
Sir, it is 3-chip
Yeah, but
camera.
what is a CCD?
Charged couple devices.
Okay, what does it do? How does it react to light, and how does it give you the image? The image consists of thousands of pixels. How does it generate the pixel?
In frames, sir.
Sorry?
In frames.
In frames, how does it generate that picture? How does, what is a pixel? A pixel is a dot. Each image has thousands of dots. So how does it recognize those dots? It has to do with excitation of protons. All right?
Okay,
Photon to electron conversion takes place. It's like, you have 300,000 pixels perhaps in a camera, and compared to that, a human eye has 5 times more pixels, as it were. Okay, and so excitation, when light falls on this grid, as it were, then there is an excitation, and a photon to electron conversion takes place. That converts further on into a minor small electrical voltage. And each of those is read by the camera, the machine, as a particular dot. And all dots are, you may have thousands and millions of colors, but they can all be reduced into RGB, red, green, and blue, 3 basic colors. And the various combinations of these 3 gives you so many other colors. Okay, that gives you the hue, the saturation, and the color. The light gives you the brightness. Okay, so what's the difference between a single chip and a 3-chip camera? Vinod, you want to take that?
Sir, primary colors, it can 3-chip can detect individually 3 colors, and it can produce different colors, almost similar to the.
What's a single chip then? All right, a single chip is designed in such a way that it recognizes all 3 primary colors, RGB. Okay, so its efficiency is less, particularly when there is some bleeding. Then you find that R, the red, takes a predominance, and the rest of the things become subdued. And so you do not have the kind of clarity that you need, particularly when there is bleeding, in a single chip camera. Whereas a 3-chip camera has 3 separate chips, each for 1 primary color. There's a chip for red, a chip for green, and a chip for blue, so that the efficiency and the clarity of the image that you get is better in a 3-chip camera. Now, we started with single chip cameras long ago, but now most cameras, most institutions will have a 3-chip camera. Okay, and you must also know about all these features of a camera. What is an aspect ratio? Very simple. Pawan.
Sir, can you repeat the question?
What is an aspect ratio? I said you must know these qualities of a camera. Okay, so what is an aspect ratio?
Yes, sir. That
anybody?
Image.
Size of the screen, sir.
Yeah.
Height and width.
16:9. What are the other aspect ratios that you know of? Another 3:4.
4:3. Yes,
4:3. So what do these lines mean? 1920 × 1080. Resolution. So what is this resolution? What does this specify? This is an HD resolution. Okay. What is a lower resolution? What is the standard lower resolution? 640 × 480. What is 4K? Higher or lower than HD? Today's standard is 4K. It is much higher than HD. I forget the actual lines on it, but it's much higher than the HD lines here. Okay. What is this interlacing scan? What is the scanning? Progressive versus interlaced scanning. What is all this, Lakshman, asking these silly questions? Right? But you know, when we use a camera, I honestly believe you must be aware of these things, because when you are a consultant surgeon, you will be asked to, the administrator will ask you to select a particular system. Unless you know these aspects, you will not know which one to select. And if you don't select the right one, your working conditions will not be as good as it ought to be. Okay, this is not just theoretical. This is a very practical significance. Okay, the way the camera scans, you know, every time it is scanning for the image once you switch on the camera. And the way it does it can be in one progressive left to right fashion, or it can be interlaced. The image or that area can be broken down into many vertical slits, and you can do it this way. Progressive is a good way of scanning that gives you better clarity than interlaced scanning. And we all talked about the 2D image because we have one camera, but in the same camera, you just like in what we use in 3D movies, you can have slightly skewed two different kind of aspects, and you can also have 3D cameras. And of course, you know about the fluorescence imaging. And cameras must be capable of fluorescence imaging, whether you use your ICG routinely or not. If you're buying an instrument today, that is the future. In fact, it's the present and definitely going to be the future. So it's good to have the capacity for fluorescence imaging. Okay, that is what you need to know. Now, is there a requirement for the monitor to have some specifications as well? If so, what is it? What are the things that you look at? Sahana, you want to have a go at it?
We need a HD monitor, sir.
Okay, very good. That's the resolution.
And the inches of the monitor.
Size of the monitor, very good. So when they tell you it's a 20-inch monitor, what dimension are they giving you?
It is the diagonal.
Very good. Yes, correct. Next, what else should you have in the monitor?
To record, we need a...
You need an output from the monitor, okay?
Yes. An input and output.
Yeah, what inputs do you need in a monitor?
One from the video,
yeah.
One from the camera.
Yeah.
And that's also one from camera input.
Yeah, you need to have more than one input. All right. And definitely you need to have an output from there, perhaps more than one. And if you have if they say that you have a horizontal, if you have a HD monitor, all right, it must have all the proper inputs as well. HDMI, that is for the HD monitor. You must have a VGA. VGA can also give you an HD image. But if they give you an S video or an AV cable with it, or an input in a monitor, even if they say that the resolution is 1920 by 1080, it won't work. So you must have a telescope, which is an HD telescope. The clarity of your rod lens system must specify it's an HD telescope. You must have an HD camera, and you must have a monitor that is capable of showing an HD image with the appropriate cables, HDMI or VGA. And only then will your image be good. If any of these do not match, then if you don't have a HD telescope, having an expensive HD camera and an expensive HD monitor is useless. Okay, so please remember, as a surgeon, you have to have an eye on all these things. All right, any questions so far? Comments, Ravi, Niranjan?
No, sir, I think it's we are learning a lot.
All right. All right.
Nothing, sir.
Okay. All right. So what is special about hand instruments in laparoscopy? We are coming to the last section. I know it's nearly 10 o'clock. We'll take another 5-10 minutes and finish it. So what is special about hand instruments?
They are insulated.
Very good. Many of them are, yes.
The
length is the first one, right? We only have 6 to 10 inches usually in open surgery. Laparoscopic instruments are 15 to 18 inches long. And because you cannot put your hands in. They almost always have articulations, which means you can rotate it. You can rotate it and you can connect it and disconnect it so that you can clean it better. As you said, insulation is important. And however good your instruments are, because they're thin instruments, most of them are 5 mm, occasionally you have a 10 mm instrument. It's not very, very strong. So you can break these or bend these if you're not careful. And above all, the grip is important. Okay. So can you tell me if anybody has thought about the grips of your instrument? I'll have to go back because the answer is right there. I've talked about a Thinar grip and a Kusheri grip. What are the kinds of grips that you are familiar? Because why? Okay, let me go back. Why is the grip important to you? There is so much of axial rotation. Unless your grip is comfortable, you will end up with wrist pain and cramps in your thenar muscles. Okay, so the grip is very important. Let me just go through it because I do not think you would have thought about it or read about it. There are many ergonomic handles with different kinds of grips. This is called an axial grip. Many of our suture, the needle holders, that's what I was looking for. Needle holders have this. Okay, there's a thing called a vario handle. I've never used it, but it gives you the best comfortable pressure with the least pressure, I'm told, on the fingers, because there's a little ball which sits in the hollow of your hand. The ring handle is good, but it puts a bigger pressure on your rotation. Okay, and the shank handle is perhaps one of the better comfortable handles because you have a shank here to support 2 or 3 fingers and a little straight thing there to support your thenar eminence. So all these are the kinds of handles, and these are important in your laparoscopic work to reduce strain. Okay, so I'll just have a couple of slides about something unique in an OT setup. So can you think about whom shall we ask? Jivita, you've been quiet for a bit. What would be special in an ideal laparoscopic OT compared to a normal OT, open surgery OT?
The positioning of the monitor and the instrument trolley.
Okay.
To the surgeon and the assistant, sir.
Mm-hmm.
And
how
the table.
How is it different? How is it different?
Like the primary monitor should be.
Laparoscopy, you're standing in all sorts of places around the table.
So multiple monitors.
Multiple monitors which are capable of practically rotating 360 degrees.
Yes.
That is what is required. Okay. And I keep talking about this. Size is important. Why can't you have a small OT in a laparoscopic OT? There are so many instruments, so many extra instruments in laparoscopy that you need to have a good sized OT. The height must be 15 feet at least. Not many OTs may actually have it. Why would that be required? Why am I even talking to you about all this? Because I keep telling you, as a consultant surgeon, people will ask you, how should I, okay, they're hiring you or you're going to be their consultant surgeon. The administrator will ask you all these things. What should be the specifications?
Monitor is usually attached to the roof.
All these are called pendants, right? That's what the picture is. For you to have good clearance for the pendants, you must have a high ceiling. And there must be multiple wiring across, and all the electrical and fiber optic cables can be together. But if you have, what is a Cat5 cable? What does it transmit? If you want to show your video to an audience in an auditorium, what do you need? You need a fiber optic cable, right? That transmits the digital information. That goes through a Cat5 cable. And so that cable must be at least 2 feet away from an electrical cable. Otherwise, if it's in the same conduit, in the same pipe as an electrical cable, you get electrical interference and your image will be distorted. It won't be good. So you must have the when you build the OT, you must have all this in mind. Because it is pendant based, it will be a high ceiling. And it's good to have a central console. All the modern OTs will have a central control for the lights, for the insufflation, you name it. These carts need not be the only thing. You can have voice activation, and it can all be hooked to the electronic medical record. And so if you have a very fancy OT, you can have something like this, looking like it. Everything moves all around, multiple monitors, rotatable lights, rotatable pendants, and a central control. Okay, this is not just a diagrammatic representation. Some fancy OTs, even in India, have all this. My last slide is on ergonomics. What is your understanding of ergonomics, Praveen?
No idea, sir.
No idea. Nikita?
For the complete efficient performance of the surgeon, what are the things we can do practically to implement, sir?
What are the things, and what are you referring to? If you have a HD camera, it is good efficiency. Is that ergonomics? It is the physical arrangement of yourself, your body, and the way it is related to the instruments that you use, and the way you position the patient and the monitors. This physical arrangement that goes into doing your operation is ergonomics, okay? So it is work, ergon means work, and arrangement, no most. It's a physical arrangement that is important. Study of people at work in terms of equipment design, workplace layout, safety, efficiency, productivity, and training. This is the subject of ergonomics, okay? And a lot of things have to be done, OT design, instruments, ports, okay? And this surgeon's stance, the way he holds himself is very important. So instead of going through this, I want you guys to read up about it a lot, but I'll give you a little brief, overview of this. You must have, in fact, Herschel, one of our earlier students, published a paper on ergonomics in laparoscopy. So I think it's a paper worth studying. You will know what we have had to convey in that. Okay, so what you have to do is make sure that you have an easy, relaxed stance. Your pelvis should not be tilted. Both feet must be firmly on the ground. Your elbow must be at a level higher than where you hold the instrument. Holding the instrument like this, where the elbow is lower, is incorrect. Shoulders should not be crouched. It should be nice and flat. And the monitor must be at the level of your eye, or perhaps a little lower. You will find that in most of our arrangements as we work even today, the monitor is at a higher level because that's the height of the stack that you have, and that is not an ideal arrangement. All right, and the head should be either straight on or slightly flexed. So the next time you operate, please bear this in mind and make sure that you're not uncomfortable, particularly if you're doing a long operation or if you're doing something complex like suturing. Okay, if you're good at it, you will find that you won't find much fatigue. But if you're doing a long operation with a lot of suturing, by the time you finish the operation, you end up with neck pain, shoulder pain, cramps in the hands and the works. And so you should avoid that by giving attention to ergonomics. We can perhaps have a whole class on ergonomics some other time. Okay, so that brings me to the end of this discussion. Let's take the questions first and then the final comments from Ravi, followed by Niranjan. Okay, questions, comments, doubts from students? Okay, Ravi, your comments?
Sir, I think as usual, it was extremely informative and useful, and with lot of practical tips and also the in-depth knowledge of the equipment that we use. I think it is important for us to go through this again and again so that, as you said, because when you are the surgeon in chief, you are probably the most important, or at least important person who should know everything about the thing, so that you can tell people what to do if things don't work. So I think it's very important. I think it's good lessons to everybody.
Niranjan?
Sir, it was excellent and comprehensive, sir.
Yeah.
Everything was covered. Thank you.
Okay. Thank you very much and good night, guys.
Good night.
Thank you.
Thank you, sir.
Thank you, sir.